I'm on to the next phase of the project, which is installing a hydraulic clutch. And the reason I'm doing this is once again because my back was hurting and I cannot take the torque force required to push the mechanical clutch. Now you'll notice not only is there a hydraulic setup here, I've also purchased the setup for the brakes. And although I wasn't planning to do that, I decided that I really hate the master cylinder in this car, the dual master cylinder, which is not really a dual master cylinder. And it has a lot of problems on itself, and then the pedals themselves are too close to me, even though I'm not very tall. So they interfere with the steering wheel, my legs. So I decided I am just going to get rid of those pedals. And the car is far from original at this point, so I'm going to install a nice set of Tilton pedals. And what I'm doing is I'm keeping the original gas pedal. So the modifications are not too severe here. I'm preserving the firewall, but I am having to mount the pedals low right on the frame basically. So I had to cut out a little bit of the floor in the front there. And then I'm using this pre-made very heavy-duty steel plate, and I'm going to bend the bottom and basically weld that to the frame to provide a very sturdy support for the pedal cluster. You will see that when most people install these types of aftermarket pedals, they push the firewall forward, sometimes quite a bit by several or 3-4 inches. I can't do that because otherwise I wouldn't be able to reach the pedals. So I had considered pushing the firewall forward and then like artificially putting the pedals back just, for someone in the future. But I said, well, why am I going to go through all that work when I don't want the pedals so far away from me? Here's a look at that plate, which I've modified to fit the car. And I decided to make it completely bolt-in, and I'm a lot happier about that rather than welding stuff to the car. So these are all threaded holes. This will bolt to the firewall, and these two actually bolt through the pedal cluster right into the frame. So this is going to be a very sturdy installation. And as you can see on the clutch side here, I had to move the holes because the advertised perfect CNC machining job doesn't actually fit all the Tilton pedal clusters. It fits the hanging cluster, whereas this is the underfloor cluster. So I didn't feel like finding one that fit, the exact one that I had. So I just moved them. It was no big deal. And I didn't bend the bottom. I actually cut it off and re-welded it. Here's a look at the plate installed, and you can see these little corner pieces. Not only do they serve as like a gusset to strengthen the plate attachment to the frame, but they also block out the outside from the inside. Okay, I have temporarily installed the pedal cluster with the aim of getting the clutch working, and you can see out here that I've got just the clutch master cylinder in there. And the reason I wanted to do that is because I wanted to see how much force is required to push the clutch pedal. And the object of this entire thing is to reduce the effort on the clutch pedal. So I wanted to see if I need to buy a booster to boost it further. And I have everything bled and it's working. You can see the pull slave over there. And if you want to see some of the details of how that's installed, check out my other video on the transmission installation. So it is working, but it is still too stiff for my taste, or actually I should say for the taste of my bad back. It rotates my back and it hurts it. So what I am doing is I am going to be buying a hydraulic booster, a single line add-on hydraulic booster to reduce the effort here. And I was curious, how much force are we actually talking about? So I measured it, and I measured two cars that I'm able to drive okay. My 67 Fiat 1100 has 19 pounds of pressure, and I just measured it very, actually it's pretty accurate, but I took a digital scale and I just pushed on it and noted the peak static pressure. So the Fiat 1100 was 19 pounds. My 69 Porsche 911, which I'm able to drive okay, is 24 pounds, and this car is 35 pounds, which doesn't seem like a lot more percentage-wise, but because of the angle of the seat and the way you're pushing directly forward on the clutch and not down on it like in a more of a sedan type car, it torques your back around more, believe it or not. And you don't notice this unless you have a bad back. So what I'm going to do, based on these numbers, is buy a booster. And boosters are available in 1.9 to 1 and 3 to 1 boost. So I figure if I get a 1.9 to 1 boost, I will then have about 16, like 17 pounds of force. Here's a look at the booster that I got for the clutch. This is the 7-inch version, which is about 2 to 1 boost. There's also a 8-inch version available, which is like 3 to 1 boost. And I'm glad I got the 7-inch version because it's a lot heavier and bigger than I thought it was going to be. So it's a single line booster, and this is from an MGB. The larger one is for like an Austin Healey. And it comes with a bracket to mount it, which I'm going to use, and then a vacuum hose. And here it is mounted on the right-hand side of the engine, on the frame rail here, sort of like on this little flange that comes out. It's pretty stable, just bolted there. And you can see it actually kind of fits in there pretty nicely. I think the 8-inch one would also have fit okay. See if we can zoom around here. Also, there's my my new starter motor. It's a gear reduction starter motor. The vacuum line runs up to the manifold, right up to this rear port, which had a fitting for the windshield washer here, but I've replaced it with a much larger takeoff, and then I'm going to tee into it to get the washer vacuum back. With the booster now successfully installed, the last step is to install the brake master cylinders. And I've got two master cylinders here. One is 5/8 bore, one is 3/4. Now, I would have actually started with a larger bore diameter, except that I saw a company in England selling this setup with this exact bore diameter for an XK120. And I figured that they must have experimented with it and done some research and some field experiments to show that it actually works. And I wanted the smallest bore possible to have the lowest pedal pressure possible. What happens is, as the bore diameter gets smaller, you get a longer throw, but less effort because you're making more pressure. So the other thing I'm going to be doing, in addition to removing the original master cylinder, I'm going to remove all of the brake lines from the car, which are currently 1/4 inch diameter, these ones here. And I'm going to be replacing them with 3/16 inch diameter. And I've been wanting to do this sort of experiment for a while on these 120s because the brakes are notoriously difficult to bleed. And I've always wondered if it's because of the master cylinder or because of the diameter of the brake lines. But bleeding other cars with 1/4 inch brake lines from this era, they're also very difficult to bleed sometimes. And my belief and thinking is that air bubbles get caught inside this large diameter line, and so the fluid kind of runs past them and it leaves these air bubbles in high spots in the line. Oh, and I forgot to mention the reduction in pressure was a success with the clutch. It was without the booster, it's in the low 30s, 30 pounds on the pedal. And with the engine running and the booster, activated, it's about high teens, so like 18, 19. It's hard to get an exact, pound measurement, but it basically cut the pedal pressure in half, and it is super noticeable. Okay, so I have installed all the new 3/16 brake line, and it worked out very well. It was much easier to bleed the brakes. And I believe that was down to air bubbles getting caught in various places, like in the front drum lines where it goes like this, and air bubble would tend to stay at the top and the fluid would go around it. Or it would float back up and wouldn't get all the way out and then just float back up. Whereas with the smaller diameter lines, the air doesn't move as fast. It can't seek its own level as fast. So you can see that I installed the brake switch here, the pressure switch in the front master cylinder. And I reused the 5/16 lines coming from the original reservoir down and spliced them into the Tilton masters there. Now I have driven the car, and the 5/8 master cylinder is not large enough in diameter to run the front brakes. And I really did sort of suspect that this was going to be the case, and the only reason I went with the 5/8 diameter, which is the smallest diameter you can get, is because I saw someone else do it. And I presumed that it worked for them, but evidently it doesn't. So you have to double pump the brakes with the 5/8 master cylinder, and obviously I don't want to do that because it's a little unpredictable and scary, actually. So I'm going to have to go to get another 3/4 inch master cylinder. But in the interim, I've actually switched the lines, so I'm running the front brakes with the 3/4 inch master cylinder, just so it'll pump enough fluid, because the front brakes have two slaves. They need more fluid volume pumped, and the rear brakes have one slave per wheel. So you might wonder why I didn't just calculate what the master cylinder size should be. And the reason is that it's actually a very difficult calculation. And this is a book that I have about brakes, which is an excellent book by Fred Punn. And he goes through the calculation, and you have to know a lot of data, experimental data, like the coefficient of friction of your drums and your pads, and weight transfer, and the coefficient of friction of your tires to the ground, and leverages, and pedal ratios. You have to know a lot to actually get down and finally be able to calculate what your piston area should be. So usually what people do is they just install a couple that they believe are close, and then they play around with them from there, which does cost a little bit in having to buy master cylinders, but you can always resell them, so it's not a big deal. And here is a look at the installation from the top side. I think it looks pretty tidy. The one thing you could do a little different is to install another reservoir, an original reservoir, and then run the line down to the clutch, so you'd have two reservoirs up here. Okay, after a few weeks driving with the 5/8 and 3/4 master cylinder, I decided to change the master cylinder size. And I realized that I'm getting into some nitty-gritty, less than glamorous details, but I figure anybody who's watched this long deserves it. So what I did was I bought a 13/16 master cylinder after some careful considerations. And I put the 13/16 on the front and the 3/4 on the rear. And this setup is absolutely perfect. And the reason is that the pedal doesn't go to the floor anymore, which it did with the other setup, the smaller master cylinders. and it's actually quite firm, which is kind of a first for me in an XK120. With the smaller cylinders, every so often the pedal would go all the way to the floor, and I'd have to double pump it. And that's owing to the, all the slack being taken up in the slave cylinders. So I'm very much liking the setup now with 13/16 and 3/4. I didn't go with a 1" because I felt that would just be a little bit too much pressure. I wanted as little effort as possible without, without going to the floor. So I had considered getting a 1" and a 13/16 and then using power brakes on the front. But that was just a whole nother complexity that I didn't want to get into unless I really had to. So the only downside of this setup that you can see here is that this bolt kind of sticks out and your heel catches it a little bit when you're running the accelerator pedal. So I may trim this off because it tends to move the balance bar around a little bit, so you'll get a slightly different balance depending on where it happens to end up. And I have set the balance up fairly well, and the way I test that is I drive the car and then I step on the brakes a whole bunch of times. I stop and I feel the temperature of the drums, all four. And you can really feel, how much force is being taken by each wheel. And you can even feel the difference between, like in the rear, if your adjuster is not quite right, you can feel the difference there. So a better way yet to set up the threshold braking is to lock up the wheels on a gravel driveway. And I'm going to be doing that just here. If you look closely, you can see where the wheels lock up in the slow motion shot. And right now, all four are locking up, but you really want the fronts to lock up first for safety on the street and stability. Okay, so I think that about wraps it up for this video. I'm planning to do a driving video which incorporates my impression of the car after doing the electric steering, the 5-speed conversion, the hydraulic clutch and the pedals, and also I've installed this different bucket seat. So I'm going to do a whole driving impression video, so check that out, or check out any of the other individual videos of the installations of those other components. Okay, thanks for watching, and I will see you next time. Signing off.